In my last video, I created a Raspberry Pi rack mount temperature monitor for my server room. I received several emails regarding logging and email notification. Therefore, this video will build on the previous. I'm going to demonstrate two approaches. First, we'll log messages to an external syslog server running on a Linux NAS. We're going to use the built-in Python logging module. Next, we'll exchange data over the internet between computers with web services. We'll use SUDS, a lightweight, open-source Python SOAP client. This video will demonstrate the Pi's ability to work with other computers and OSs. I'll try to keep the tangents to a minimum, but hopefully I will show the extensibility of Python and the Pi. This will be a fast-paced video, but I will post all the code on my website, rototron.info. Syslog is a protocol for computer message logging. It permits separation of the software that generates messages from the system that stores them. I'm a big fan of Synology, but there are other open-source alternatives such as syslog-ng and rsyslog. I'll start by installing a syslog server on my Synology NAS. Syslog doesn't require a NAS. You can use any computer or the Pi. I don't like the idea of using the Pi as a logging or database server because of the high number of writes to flash storage. I also have multiple devices that generate logs. Therefore, it's advantageous to have a centralized system for monitoring. Okay, syslog is installed. Now I just have to configure two settings. First, I'll specify a folder where my log messages will be stored. I'll select Archives. The Synology has its own built-in email server. I've seen a lot of websites showing how to send mail directly from Python, but they store mailbox passwords in clear text in your code. I'd rather leverage a system that incorporates the proper security. Now, if any critical messages are logged, the NAS will notify me by email. The service is now up and running on UDP port 514, and we can start sending log messages from the Pi. I'll open up a Python shell. First, import logging handlers from syslog handler. Next, I'll import logging. Both modules are built in, so no external code is required. I'll instantiate a logger, and I'll set the default level to info. Now I'll instantiate a syslog. That's the IP address and the UDP port of my syslog server. I'll add the syslog to the logger, and I'll set up a variable for temperature, since these are temp sensor logs. Now we're ready to send the log messages to the syslog server using the info method. That's all it takes. If we switch back to the syslog server, you can see the log message. Since I use the info method, there'll be no email notification. Now I'll increase the temperature and send another log. This time we'll use the critical method, which elevates the severity of the log message. I'll switch back to the syslog and you can see the new message. Since it's a critical message, I'll be notified by email. And there goes the email. Here's the email with the log message in the body. So we've got logging and a relatively secure email notification system without much work. But suppose we want more flexibility in how we store and manipulate our data. In the previous video, I created this basic WebIO-Pi website that displays the temperature in my server room. Now I'd like to extend that page by adding a dynamically generated bar chart to show how the temperature fluctuates over time. This will require a database to store and serve log data. We'll use web services to achieve this goal. What is a web service? Basically, it's a function that you call over the internet. Not only can it return data, but it can execute code on a remote web server. I'm relatively new to Python and Linux. This is only my second project. Web services allows me to leverage my existing skill sets. I can utilize my existing C code in whatever OS environment I like, Linux, Windows, or Mac. One of the strengths of web services is its cross-platform operability. I'm very comfortable with IIS, which comes with Windows Server, and SQL Server Express, which is a very powerful free database server. Therefore, for this project, I'll write the web services in C# and host them on a Microsoft box. I'm just going to brush over the code because I don't want to digress, but for the most part, it's abstract and would translate easily to Python or to Java. This is my web services code. The class is called PyLog and contains three methods: upload log, notify, and get log. Upload log will receive logs from my Pi temperature monitor. I'll capture the IP address of the web request in addition to the passed parameters. Next, I'll initialize a database context to simplify communication with my database server. CRUD operations are then handled by a linked database record. I store the date, log level, source, IP, and the temperature, then submit them to the database server with error catching. The notify method allows me to send email notifications from the Pi via the SMTP server that's built into IIS. I'm calling the method with a name instead of an email address for security reasons. The sender will just be a no reply, but the recipient email will be returned from my database by name. This will help prevent against unwanted message relays. Next, I instantiate an email message and set the correspondence fields from, to, subject, and body. Then use an SMTP client to send the message. The IP address is my local SMTP server. The getLog method will be utilized by my WebIOPI webpage to get the bar chart data. The take parameter specifies how much data to return. I'll set up a database context and then run a query that returns the most recent sorted log entries. I iterate through the entries and package them into a string, which the function then returns to the web page. And that's it for the web services code. Next, we need to install the SUDS SOAP client, but first I'll install pip, which is a tool for installing and managing Python packages. The regular version of SUDS doesn't support Python 3, so we need to install a fork called SUDS Jerko to get compatibility with WebIOPI. Here I use pip to automatically install the package. After installation, I'll cd to user local lib python 3.2 dist packages and verify that the SUDS package installed correctly. Okay, it looks good. Now we're ready to start using web services in our Python code. This is the WebIOPI script file from the first video. I've added a reference to the SUDS client so we can consume web services. Now we will edit the WebIOPI loop method to add logging every hour. I instantiate a SUDS client. With one line of code, I can call the upload log method of my web service and upload my log data to my database server. These events will serve as the source data for my temperature bar chart. Next, we check for a critical temperature that would warrant an email notification. Again, with one line of code, we call the notify method of my web service, and I will be notified by email if it gets too hot in my server room. Finally, I create a WebIOPI macro. This macro allows the WebIOPI webpage to communicate with the Python script. getTempLogs will call the getLog method of my web service and return the temperature data. Here's the HTML for the WebIOPI webpage. I've added the function call getTempLogs macro. This will call the macro in our Python script and request 24 hours of temperature data. The script will then call my database server via web services and return the data to the callback function call getTempLogs macro callback. This function will then pass the data to a JavaScript method I created called buildChart. It will use the data to draw the chart on an HTML5 canvas. I've set the onload event of the body to draw a chart when the page loads. Finally, I've added an HTML5 canvas to contain the chart. Here you can see the bar chart on my WebIOPI webpage. The chart plots my server room temperature for the past 24 hours and provides a helpful picture of the temperature variations during the day. Looks like the room is staying cool. This video was meant as a brief introduction to the concepts of logging in web services. I know it was very quick, but all the code is available for download on my website, rototron.info. Thanks for watching.